example, we have a list of else, r's, and underscores. We want to find the total maximum travel. If we replace underscores with r or else, the solution is just brute force replace all to r and check, and then replace all to l and check again. Now to simplify the formula, you can say that you always include underscores, because if you're replacing them to l and check for the l, you obviously count them, and if you check for the r and check for the r, you also count them. Now also you don't have to like check, you can check just balance, because this is a result. Because if you travel to the left, then travel to the right, then again to the right, and then to the left, the result is just like sum of all else minus sum of all r's, and then absolute value, because the l can be bigger or r can be bigger, it doesn't matter. What's matter is distance to 0. That's why you taking this apps value. Let's look at the code. This is my implementation. I use separate counter and I use apps absolute value. Now let's look at the goal solution. It's kind of unexpectedly interesting. You can see this is 2 times LR maximum, this count is not equal C minus length, so it's kind of cryptic and you can't just tell what it's doing. I try to explain. So let's start from this formula, or actually let's start from the formula that was accepted. So count underscores plus absolute value L minus R. This is what my expected formula was. And now let's look at the geometry of this this formula. So first, this is underscores. The underscores is if we take all this length of all r's, l's, underscores, and then remove all r's and l's. So this is would be the total length minus l plus r. This is underscores. What is underscores? Now let's and then we say this, we can replace it. So this is a plus L minus R absolute value. So now we can expand this mathematically or geometrically. Let's try with geometry. So the first is the length, the total length, and this is L plus R. So let's take this yellow is L and this green is R. So let's make green a little bit bigger, for example. Now the L plus R and plus underscores, so this would be underscores. This is entire length. Now the L minus R is the difference, so take the yellow, it's shorter, and this small difference is called it will be L minus R apps. This is a short difference. Now in our formula for, so this is formula. So in our formula we take this length, then we remove this part, and then we add back this part. So geometrically we can say that this part is is yellow, green plus yellow and minus 2 yellows, because if you look at this is 2 yellows, I would say two minimums of LRs. This is what it is. So I we kind of arrived at the formula of m length minus 2 minimums of LR. So the final formula is like the length minus and then 2 minimums LR. So this is a final formula. We gone from this one, where we take underscores plus apps L minus R, and the final formula is the total length minus 2 minimums LR. So if you take the underscores, this would be underscores. Look at them. And the absolute of L minus R is this one. So we're removing from the entire length, we're removing these 2 yellows. This is a final formula. I hope I explained it now. And we can rotate this formula for the final solution. So 2 LRs maximum, and this m count it not equals c is just the trick to find the underscores plus some value. So for example, underscore plus L is when we take an R. So this is solution. Now let's look at the RAS solution. The RAS solution is also interesting. I wouldn't publish this, but I would explain it. So we take 3 elements, array of 3 elements, and then we take iterating from bytes of the string and taking modulo 5. So modulo 5 gives us perfect a reminder of 0, 1, 2. It happens to be so, and then we take the final step. So 0 would be underscores, and this is what our formula was. And also Rust has a similar solution, and this is what I would publish. That's it for today.